Welcome to Hot Topics. I got a question from a Saudi engineer in Saudi Arabia working for Aramco. Two-part question. His first question was, do we do Zoom videos that Aramco could request? And yes, we do. We can do just about any type of video on codes and standards as we have done for Aramco in the past. Just contact me at Grayboy, lowercase, GRAYBOY, 02 at AOL.com. Now, the second part of the engineer's question was, can you backfeed a transformer? And as you see in this illustration, which is 2045 and Stallcup's Electrical Design Book, Volume 2, yes, you could. You're just basically turning the transformer around and you're supplying it with a feeder from the service equipment or sub panel to the 208 volt side. And then the 4080 volt side, will supply the load. Now, as you see in the illustration, this NEC 450.11b requires any designer or installer of a reverse fed, back fed type transformer, first of all, to apply this note 4. They must always check with the manufacturer of the transformer to see if even they recommend that it can be back fed, and if so, are they any major losses and the voltage drop or the reduced current rating on that 480 volt side, because you're supplying the 208 volt side. And then course number 3, very important, never connect the XO to ground as you see in the illustration. It just floats. It's not connected to ground or a neutral connected to it or an equipment ground connected to it. It just floats. Now, equipment ground can be pulled in and bonded and grounded to the chassis ground for fault current conditions. Now, let's start with the 208 volt side. And we're going to bring a feeder in and size the conductors in accordance with 215.2A1, little a or little b, or maybe both. A deals with 125% rule. The little b part of 215.2A1 deals when you route the conductors in conduit, say, through a higher ambient temperature than 86 degrees Fahrenheit, and all this is outlined in section 310.16 in the NEC. Now, of course, if you have 4 more current carrying conductors in that feeder supply on that 208 volt side, then you have to apply table 310.15 C as in car 1 and derate and reduce the ampacity of those conductors, as you can review in our videos on James Gray Stallcup Electrical Design Institute, Training Institute. Now, looking at that secondary side, then we kind of get a feel for what's required for the conductors, sizing of them, and so forth. Now, another thing you have to look at on this 208 volt side, you're going to have a very high inrush current when you first, energize the transformer. Now, that could be up to 37 times. Now, the peak current, you can kind of find your peak current by taking 1.414 times the voltage. Divide that by the resistance of the windings, which you'd have to get from the manufacturer, and that will give you the peak current. Now, the inrush current then can be found by taking that peak current and dividing it by the full load current rating of the transformer, and that will give you basically what the how how bad the inrush current could be. And like I say, it could be anywhere from 15, 25 to 37 times the full load current of the transformer. So you have to keep that in mind, because usually you always have to size your overcurrent devices larger than table 450.3 B as in boy in the NEC will allow. Now, going to that secondary side that we're going to look at here and call it the 480 volt side in this case, and we're going to feed the load with that. Now, notice you design those in the same way. You take 125% of the load. If it was routed through an ambient greater than permissible by 310.16 in NC, usually that's about 10% of the run, or 10 foot, whichever gives you the best rating. So you keep that in mind. And then you have to determine, are you going to apply the tap rule? And this would be, really called secondary conductors in most cases, but it is a tap. So you would look at 240.21 C as in car 2 for a 10 foot. Any tap over 10 foot up to 25 foot, look at 240.21 C3. And that's considered an industrial type tap. If you wanted to tap more than 25 foot, then you would have to review 240.2 of the NEC and determine if it was an industrial supervised location. Then you could tap over 25 foot up to 100 foot by 240.92 C as in car. If you wanted to tap any length, then you could apply the application and formulas, design it properly in accordance with 240.92E as in ed. And then, of course, you have to determine, are you going to run it ungrounded, or are you going to corner ground it? Corner grounded, as you see in the illustration, is 250.26, item number 4 in the NEC. If you're going to operate it ungrounded, look at 250.21 of the code, and then, of course, you're going to have properly designed grounding sensing relays and other type of protection from overloads and things like that you would want to make sure you provide. And that is a design preference. You have to design it so that you protect those conductors. Now remember, you protect conductors in accordance with Article 240. The transformer protection and so forth is in Article 450. Now these are the basic rules that you would have to apply if you reverse feed a transformer. I hope that this information will be helpful to all of our viewers on YouTube, and I hope it's beneficial to you. My name is James Gray Stallcup. Thank you for watching, and have a blessed day.